Welcome, I'm m.felicetti, and in this video we're looking at number systems. Okay, so when we're programming, we actually need to use a range of number systems. The number system that everyone is used to is decimal because you use it every day. But often it's the case that we are so used to it that we often don't think about how it works. So we're going to quickly start off looking at decimal as to help us understand other number systems. So in decimal, a digit can be 10 possible symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Then we have a positioning system, whereby the position of a digit within a number indicates the magnitude of that quantity. So let's have a look at an example to make sense of that. So let's have a look at the number 44,678. You'll notice that I've put the subscript 10 there to show that our number is in base 10 or in decimal. So firstly, each position is assigned a weight, where the weights are positive powers of 10 that increase from right to left. The value of a digit in a position is the multiplication of the digit's value by its weight. Now, we then can calculate the value of a number by the addition of all the digits by their weights. So in this example, we add that up and we get 44,678 as expected. Now, this might all seem fairly simple, but it is very important that you understand this to understand number systems. Also note, we're not going to worry about fractional numbers or negative numbers at the moment. Now, the next number system that we're going to look at is binary. And a binary digit can either be 0 or 1. And this is how data is stored and transferred on a computer. And so it's very important to understand this when programming, as this is the way your data is actually going to be stored and used on a computer. So binary is just another number system. However, a digit this time can only be two possible symbols, 0 and 1. And once again, we also have a positioning system, so the order of the digits matters. So let's take a look at a binary number. So I've got the number here 10101 in base 2 or in binary. So the 2 there stands for binary or base 2. So once again, each position is assigned a weight, where the weights are positive powers of 2 that increase from right to left. The value in decimal of a digit in a position is the multiplication of the digit's value by its weight. And the decimal value of the number is the addition of all the digits by their weights, which if we calculate this out, we get the value 21 in decimal. So when a computer stores 21 in decimal on a computer, we store it as 10101. So 10101 in binary is the same thing as 21 in decimal. Now, what we're going to look at next is counting. Once again, this is a fairly simple concept. So in decimal, I count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. However, when I reach 9 and want to count one more up, I have to carry over to the next position and reset the digit that carried to 0, giving us 10 or 10. Now this is decimal, but what if I need to count up in binary? So I start from 0, I then count up, so I get a 1. But if I want to count up further from this, I've run out of symbols. I've only got 2 symbols. So I have to carry, giving me 10. From there, I can keep counting, so I get 1, 1, and then 1, 0, 0, and so on. So this would be nice to put into a little table. So we've got decimal 0 to 15, and we've got binary 0 to 1, 1, 1, 1. So the last important number system that we're going to look at is hexadecimal, or base 16. And this is a very handy number system because it's very easy to convert to and from binary using this number system, and also it's a shorter way to write out numbers, as we'll see shortly. So in this we have 16 symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then A, B, C, D, E, F. So this might make a little bit more sense if we put this into our table. So we can see here, for example, the number 10 in decimal is equivalent to A in hexadecimal, or 12 in decimal is equivalent to C in hexadecimal. So let's go with another example, and here I have the number 5A in hexadecimal. And we want to convert it to decimal, so we can use the exact same method that we did before. So we can get the weights, we can multiply, add them up, and we get 90 in base 10, or decimal. So 90 in decimal is the same thing as 5A in hexadecimal. Now, as I said before, hexadecimal is really, really nice because it's actually really quick to convert from hexadecimal to binary and binary to hexadecimal compared to the conversion to decimal, which requires a little bit more work. So often we'll usually use hexadecimal and binary quite a lot, and decimal when we need it for more mathematical operations. So here, if we have a look at our table, we can see A on our table. And this is the same thing as 1010 in binary. So A in hexadecimal is 1010 in binary. So let's write that down. And if we have a look further in our table and look for the 5, we can see 5 in hexadecimal is equivalent to 0101 in binary. And so the conversion is quite simple. We can just use this small table to convert between binary and hexadecimal rather quickly. And with enough experience, you won't need the table, but for now, you can use it as much as you need. Now, from there, this is just a quick introduction to binary, hexadecimal, and number systems. There is quite a bit more. So, for example, negatives, fractions, addition, subtraction, multiplication, division, and other conversions. But this is enough to understand the concept and start using them in your programming. Thank you very much.